David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic is a review of solving quadratic equations. So we're going to go through all the techniques we did in that chapter. Okay? If any of these things in this video are confusing to you now, then what you want to do is drill back in and watch the specific video for that technique. First thing we did, we solved equations that were in this form, x squared equals k, k being some constant. So sometimes we had to manipulate the equation a little bit to get it to look like this. For example, this one, 4x squared equals 16. I'm just going to solve it by dividing by 4 on both sides. X squared equals 4. 16 divided by 4 is 4. Now I can take the square root. So the square root of x squared is just x square root of 4 plus minus 2. Remember your plus minus. Probably one of the most common errors when people do these kinds of problems. Let's take a look at this one. I'm going to subtract 50 from each side. That leaves me with 3x squared equals 150. Now I'm going to divide through by 3. It's going to give me x squared equals 50. Take the square root, x equals plus minus root 50. Now, you're on the hook to simplify radicals. So the square root of 50 is the same as the square root of 2 times 25, and 25 is a perfect square, comes out as its square root, which is 5, leaves the 2 inside, so this is plus or minus 5 root 2. Now, there were a bunch more of these kinds of problems, and if you need to drill back into that problem set, pick some of the other problems, you can do that. Okay, we also had some more complicated ones where we had a binomial squared. It's still the same general idea here, except the thing that's squared is a little bit more complex. But same process. So for this one, we're going to take the square root of both sides. That's going to get rid of my squared there. So I have x plus 1 equals plus minus 3. So I have two solutions on this side. So let's take this one step further. I'm going to subtract 1 from both sides. That is negative 1 plus minus 3. So now I have two answers. I have negative 1 plus 3, which is 2. And I have negative 1 minus 3, which is negative 4. So those are our two answers. So remember, when your root resolves to an integer without the root, you need to finish off by finding out what two numbers that make our solution. Whereas with this one, we just had a radical in there, so we're okay leaving it as just plus minus. Okay, let's do this last one. Take the square root of both sides. X minus 3 equals plus minus root 40. Now root 40 is a radical that we can simplify because 40 is 4 times 10. 4 is a perfect square, comes out as its square root, which is 2, leaving the root 10 inside. So this is plus minus 2 root 10. But we're not done. I still have a negative 3 over here. I have to move over by adding to both sides. So now I get x equals 3 plus minus 2 root 10. And this one we can leave right here an ugly answer. So whenever you have radicals out here, you just leave it as an ugly answer. It's only when the root becomes an integer without a radical that you then figure out what the two solutions are. The next thing we looked at was the Null Factor Law. And we did one lesson on just that, and then we used the Null Factor Law quite a bit throughout the rest of the chapter. So the Null Factor Law is pretty simple. What it says is if you have two things that are multiplied by each other, if you know that the product is 0, then you know that at least one of those two factors has to be 0. There's no other way for that to be. So if we have this quadratic, 6x times x minus 3, and we set it equal to 0, then we know that either 6x has to be 0 or x minus 3 has to be 0. And when we solve these quadratics, actually we're looking for two solutions that make this whole thing 0. So what we do is we do a little branch. We branch this one out. 6x, that's our first factor, equals 0, and we solve it. So we just divide through by 6. That leaves us as x equals 0. So there's one solution. Now we branch it and we check this one. X minus 3 equals 0. Now I have to move my 3 over, add 3 to both sides, and I get x equals 3. So here are my two solutions for that quadratic using the Null Factor Law. Now if you want to give it a shot, try that one. A little bit more complicated, but not by much. Okay, I'm going to do my branch. X plus 4 equals 0. Subtract 4 from both sides, and I have my first solution. X equals negative 4. Do my second branch. X minus 12 equals 0. Add 12 to both sides, and I get x equals 12. There's my second solution. Okay, the next thing we did is we solved quadratics by factoring them and then using the null factor law to find our solutions. So I'm going to do 3 examples here. If you're feeling bold, pause the video right now and give them a shot. Okay, now the trick here is you've got to remember all your factoring patterns from that chapter in our book. So x squared minus 16, if you look at that, you'll realize this is a difference of squares. So I can factor this into x plus 4 times x minus 4 equals 0. That's the factoring. Now this ends up being x plus 4 equals 0, which gives us our first solution as minus 4. And this one is x minus 4 equals 0. Our second solution is x equals 4. So we have these 2 solutions. Okay, so recognize factoring pattern, factor it, set each product equal to 0, each factor equal to 0, and solve. Okay, look at this problem. See if you can do that. Did you recognize that that's a perfect square? Here's how. X squared is a perfect square. 36 is a perfect square because it's 6 squared. So if this middle number is twice the square root of the end number, then we know we have a perfect square. And it is. Square root of 36 is 6, twice 6 is 12. So now I can just simply factor this into x minus 6 squared equals 0. If you're doing a perfect square, then this number is always half of that number. If you're unsure, you could FOIL this out and you should wind up back here. Okay? Now this is one of those x squared equals k problems that we started this video with. So I take the square root of both sides, x minus 6 equals 0. Square root of 0 is still 0. This is super simple. So this one has one solution, which is x equals 6. Okay, try that last problem. You probably noticed I changed it a little bit. I wanted a better problem for that. So give it a shot. That's a split the middle term, which I think is one of the more challenging factoring problems that we did. Okay, let's see how you did. So the first step, I multiply my a by my c. So ac equals negative 6. Now I need 2 factors of negative 6 that add up to negative 5. And those are negative 6 times 1, which is negative 6, and negative 6 plus 1, which is negative 5. So there I have it. So I know how I have to split the middle term. It's negative 6 and 1. So let's do 2x squared minus 6x plus x minus 3, like that. Now I factor each pair. So I've got a 2x in both of those. So this becomes 2x times x minus 3. Now I already have an x minus 3 here. So I use that trick where I take out a 1. I factor out that 1. So there's 1, and this leaves x minus 3 inside. Finish off. 2x plus 1 times x minus 3. What did I forget on this entire problem? Think about it. What's missing? Equal to 0. Okay, now I have my branch. I need to solve this one. 2x plus 1 equals 0. Move the 1 over. 2x equals negative 1. Divide by 2. X is negative 1/2. This one's a little bit more simple. X minus 3 equals 0. This gives us x equals 3. There are 2 solutions. Okay, the last factoring pattern that we used when we were solving by factoring was the product sum factoring. So this is when you don't have a number in front of the x squared term, and you find 2 numbers that multiply to the last term that add to the middle term. So let's try this one here. 2 numbers that multiply to 14 that add to 9. That would be 2 and 7. 2 times 7 is 14. 2 plus 7 is 9. So it's a one-stepper. You just go x plus 2 times x plus 9. So that gets us our factoring. Now we have our 2 branches. X plus 2 equals 0. X is negative 2. And in this one, x plus 9 equals 0, so x equals negative 9. So those are our two solutions for this one. Now, go ahead and try that one. Same idea, slightly different problem. Okay, let's see how you did. Two numbers that multiply to 27 that add up to negative 12. And those two numbers are 3 and 9, but negative. So negative 3 times negative 9 is positive 27, and negative 3 plus negative 9 is negative 12. So what we get is x minus 3 times x minus 9, set equal to 0, branch and solve. X minus 3 equals 0, x equals 3, x minus 9 equals 0, x equals 9. Two solutions there. Okay, the next technique was completing the square. Now this is for quadratics that you can't factor with integers, like this one. There's no two numbers that multiply to positive 6 that add to negative 4. They just don't exist. So what we do is we move the constant, leave these here, move the constant over to the other side. So now I'm going to subtract 6 from both sides, so I have a negative 6 out there. Now I add b over 2 squared to both sides. So b over 2 is negative 4 over 2 squared. Negative 4 over 2 is negative 2 squared is 4. So I'm going to add this 4 to both sides. X squared minus 4x plus 4. Now when I add 4 to negative 6, I have negative 2. What I've done is I've made a perfect square. So this factors down to x minus 2 squared equals negative 2. Okay? Now I'm going to take the square root of each side. I get x minus 2 equals square root of negative 2. Now, what's going on here? I have no solution. This quadratic is done. No real solution. Let's do another one. Okay, let's do another complete the square problem. This one will have a solution, I promise. Okay, so checking this out. First, let's see if we can factor it. Much simpler process than completing the square, so you should always check for that. Two numbers that multiply to negative 4 that add to positive 8. If you think about it, you see there aren't those two numbers. So what we're going to do is we're going to move the constant over by adding 4 to both sides. X squared plus 8x equals 4. Now I'm going to find my b over 2 squared. So b is 8 over 2 squared. 8 over 2 is 4, squared is 16. So I'm going to add 16 to both sides. 16 and 4 make 20. Okay, so now I have 8x, or x squared plus 8x plus 16 equals 20. This thing is now a perfect square, so it's going to factor down to x plus 4 squared equals 20. I take the square root of each side. X plus 4 equals plus minus root 20. And if you remember your roots, this one simplifies down to 2 root 5 with its plus or minus. Now I got to get x alone. It's still x plus 4 over here, so I'm going to subtract 4. X equals negative 4 plus minus 2 root 5. And that's my ugly answer. Okay, the last technique we did was using the quadratic formula. And this is that big old formula that lets you find the solutions to any quadratic equation you want, okay? So let's write that formula up here. It's x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a, okay? So that's our quadratic formula. So what we do is we plug in our a, our b, and our c in the formula, where they go, and then we just plug and chug. So let's do that. Here's our A, here's our B, here's our C. So, x equals negative b. B is negative 4, so we've got to keep track of the two negatives. Plus minus the square root of negative 4 squared minus 4 times 3 times negative 8. And a word about this plug-in step. Actually, let's finish it. 2 times a, so 2 times 3. So do it like this. Resist the temptation to actually start doing math as you plug in, like write 6 here, or get rid of the negatives there. because when I grade your test or your quiz, I give a lot of points to this correct plug-in step. If you show me that you know where everything goes without confusing it with other steps, then that's worth something. If you start doing math in this step and you make mistakes, it gets really hard to tell, and it's hard for me to tell where you went wrong, okay? So do a nice plug-in step like that. Now we can start crunching. X equals, negative 4 is just 4, plus minus, negative 4 squared is 16, negative 4 times 3 times negative 8 is minus 96. I don't need that. This is all over 6. Okay? Now let's continue. 4 plus minus. What did I do wrong? That's a plus. I have minus times a minus, so that's a plus. So this becomes root 112 over 6. Now, this number is actually a pretty nice one, because what this is going to be is 4 plus or minus, this is 7 times 16 over 6. And we like that because 16 is a really good perfect square. Let's finish this off down here. 4 plus minus, that comes out as a 4, leaving our root 7 over 6. So a final step. I've got two 4's up here and a 6. 4 over 6 is the same as 2/3, so I get 2 plus or minus 2 root 7 over 3. So there's our answer. That's one of the more ugly answers, but it's perfectly valid. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.